Okay. Visible. So good evening, everyone. So I will be taking today's class. Saurabh sir is on leave. So
Good afternoon, sir.
good afternoon.
Good afternoon, sir.
So my screen is visible. Can you see this screen? My desktop.
Yes, sir.
So this course is discrete mathematics. Okay. Okay. So let us start. So sir told me to teach the topic. Uh, this topic is relation. So I have been informed that I have to teach chapter 6, and the name of the chapter is relation. Okay, so once can you confirm again that you can see this what I'm writing?
Yes, sir, it is visible.
Okay. So we'll start with the definition. So what is definition of relation? So how do we define? So how to define relation? So this relation is not the real life relation, it's a mathematical relation, but somewhat related. Okay. So in real life, what happens? Like relation between suppose brother, sister, and a mother, father. So between two persons, you define a relation in real life. So similarly, or two family, you can say. So similarly here, we will have relation between two sets. So sets are actually families. Okay. So if I define, so what is definition of relation? So directly I'm writing, okay. So directly like any subset of A cross B. Okay. So before that, you may tell about AB, that what is AB. So we may write like let A and B are two non-empty sets. Okay. So suppose A and B are two non-empty sets, and we want to define relation from set A to set B. So we want to define relation from set A to set B. Set is a family, okay. So you may consider set as a family. So definition is any subset, okay. Any subset of set A cross B is a relation from set A to set B. Okay. So this is a definition of relation, or we also call it binary relation. Okay. So a relation from A to B is a subset of A cross B. So first of all, if I give you the note, like how do we define A cross B? So what is definition of A cross B? Uh, so A cross B. If I define A cross B, then what is A cross B? So can anyone tell me what is definition of A cross B? It is called Cartesian product of sets A and B. Okay, so it is called Cartesian product of sets A and B. So it will consist of order pairs. So you may like redefine like order pair A comma B such that small a belongs to capital A and small b belongs to capital B. So this is definition of A cross B. For example, so if I define right example, so A is a set containing suppose 1 2, okay, and B is a set containing let's say 3 4 5, okay. So A is a set having two members 1 and 2, B is a set having three members 3 4 5. Now I would like to ask you what is the what will be A cross B? So can anyone calculate what is A cross B? So then we can define that. So we can define a relation from A to, है ना, A to B. So relation from A to B is nothing but a subset of A cross B. So tell me anyone, what is the value of A cross B? What will be A cross B here? Anyone can try. You can tell wrong answer, no problem. So at least you can try. No one? So definition of A cross B is this. So definition of A cross B is this. You just apply this definition.
So all the elements in A and B, like 1, 2, 3, 4, and 5.
No, actually, it's good you tried, but we are not asking A union B. That will be A union B. Okay, we are asking A cross B. So A cross B is called the Cartesian product of two sets. So this, the name, if you write, what is this? So we are multiplying two sets. In short, you can say we are multiplying two sets. So the standard name in mathematics is Cartesian product. So Cartesian product of two sets. Okay, one minute. So so do I need to admit? Oh. Okay, so what I'm telling. So Cartesian product of two sets A and B. So name is like Cartesian product two sets A and B. So anyone, any more? Anyone would like to try again? So it will be like, see the definition. See definition carefully. What is it saying? A cross B. Look at the definition here. Okay, so you look at this definition. So it is telling A cross B is a set containing A. It's an order pair. We call it order pair. Like तुमने point देखा होगा ना? Mathematics में जो point होता है x,
Hello.
y. Yes. Yeah. What is the problem? Anyone is speaking? Okay. Is there any problem? It's not. Then we can continue. Okay. So what will be A cross B? It's the order pair AB such that first element belongs to first set, second element belongs to second set. Okay. So can you write like that? Anyone try now? First element, like you will write like order pair AB such that first element belong to first set and second element belong to second set. So you tell me that number. So what should I write? What pairs I write?
1, 3,
Right, 1 3, yes.
and then 2, 3,
2 3 is also correct, yes.
1, 4,
1 4,
2, 4,
2 4, fine.
1, 5, and 2, 5.
Correct, 1 5 and 2 5. This is absolutely right. So like what we did, we know A cross B is a set of ordered pair AB such that first element belong to first set and second element belong to second set. मैं वीडियो ऑन करके पढ़ाता हूँ बाय द वे, अगर आपको ज़्यादा प्रॉब्लम हो तो 1 मिनट. सो पीपल्स आर डिस्टर्बिंग मी. ओके. ओके, 1 मिनट. सो ओके, सो A क्रॉस B is this 1 3 2 3 1 4 2 4 1 5 2 5, fine. So what is cardinality of A? Cardinality means number of elements. Okay, so A has 2 elements, B has 3 elements. So how many elements A cross B has? You can count, right? 1 2 3 4 5 6. So number of element in A cross B is 6. And you might be knowing, I think, already that number of element in A cross B, this is same as number of element in A into number of element in B. So this thing I'm telling you because these are basics and I will be using it. So now I will find number of relation from set A to set B. So for that you need to know this. Okay. So A, I took set containing 1 2. A has 2 elements. B, I took set containing 3 4 5. So B has 3 elements. And A cross B, so A cross B is called Cartesian product of two sets. So how we multiply? Definition is it's a set of order pair A B such that A will belong to the first element belong to first set and second element belong to second set. You have to write all that order pairs. So like one of you told na 1 3 2 2 3 1 4 2 4. So like 1 3 1 4 or is it only 1 3 2 3 1 4 2 4 or 1 5 2 5. So like these are all order pairs such that first element is in first set and second element is in second set. Okay. So now I will come to definition of relations. What is saying? A and B are two non-empty sets. Just for information, the definition is any subset of A cross B is called a relation from set A to set B. So you want to establish a relation from set A to set B. Okay, relation. So like I will write R. R means relation here. A has 1 2, B has 3 4 5. Okay. So A has two elements 1 2 and B has three elements 3 4 5. So what I would like to ask, since we already find, so I would like to repeat it. A was 1 2, B was 3 4, no sorry, B was 3 4 5. Is it? Yeah. So B I have taken 3 4 5. So who is he? Who is speaking? Yeah, do you have any problem? Anyone? Okay. Okay. So what I'm telling, A is a set containing 1 2, B is a set containing 3 4 5, and A cross B we have. So I will write the same way like she told. 1 3 2 3. Okay. 1 4 2 4, 1 5 and 2 5. Okay. So now the question is, we want to define a relation from A to B. So why we calculated this A cross B? Because the definition was involving this term. So any subset of A cross B is a relation from A to B. Okay. So now my question is, can you tell me any subset of this set? So A cross B is a set and it has six elements: 1, 2, 3, 4, 5, 6. Like I've written here also, n of A cross B is number of element in A cross B. So number of element in A cross B is 6. So here number of element in A cross B is 6. So definition is any subset of A cross B is a relation from A to B. Okay. So tell me any one subset, any one subset. So if I ask you total number of subsets, total number of subsets of A cross B, can you tell me how many total subsets are there? Total number of subsets I'm asking. So anyone can try. Since A cross B has six elements, so tell me total number of subset of A cross B. So how many subset will A cross B have?
36.
36. Good, you tried, but this is a thought. 1 minute. Let me ask. Let me check. So 36 means 2 raised to power 6. You want to tell? 2 raised to power 6 is what? Tell me. 2 raised to power 6 is what? Is it 36? No, I think. So you tried good, but it's not correct answer. So correct answer is 2 raised to power 6. Calculate it. What is that? 60 into za 32 to za 64. Am I correct? You just check it.
64.
Yes. So there are 64 subsets of A cross B. Means we can define 64 relations from A to B. You know that? Just I'm following definition. So definition is any subset of A cross B is a relation from A to B. So in exam, suppose they ask you how many relations can be defined from set A to set B. So like I told you example, but I will tell you formula also. So the here total number of subsets of A cross B is 2 raised to power 6, 64. Means total number of relations from set A to set B we can define is 64, because any subset of A cross B is a relation from A to B. So first we calculate A is this, B is this, A cross B is this, then total number of subset is this. So how I get this? So because there is a formula. So what is the formula? So if I write the formula in the remark, let me write it at bottom. So I use two concept. So if number of element in set A is suppose m, okay. So n m is number of element in set A. So number of element in set A is m. Then the formula is total number of subset, okay, of A. So since A,
Raj,
then what is that? Total number of subset of A. Yes, anyone would like to tell the formula of this? Like if you have noticed, then here, do you notice anything? Like A cross B had 6 elements. So I told that it has 2 raised to power 6 subset. That is 64 subsets. So can you generalize it? And can you tell me the correct formula? Like if set A has m number of elements. So what is the total number of subset of A? So how many subsets you can define on set A? Anyone? Quickly, you may notice something here. Notice from here. I wrote total number of subset of A cross B is 2 raised to power 6. Why 2 raised to power 6? So using that, can you tell me what should I write here?
So 2 to the power m.
Correct. So 2 raised to power m. So the answer is, so formula is we have 2 raised to power m. Okay. So if any set has m number of elements, so it will have 2 raised to power m subsets like I have used here. So this is one formula I used. So similarly, now, so the one formula I will write here, this I write formula for this. Now I write formula for this. So second formula is like if suppose number of element in set A is m, and or instead of m I write something else. Suppose I write p. So there are p number of element. P is some number. Okay. So or if you wish, you may write m1 and m2. Okay. So suppose set A has m1 number of element and set B has m2 number of elements. So m1 m2 are two numbers. So number of element in set A is m1 and number of element in set B is m2. So then number of element in A cross B. Quickly you tell anyone. Number of element in A cross B. So again you can notice I have already written the formula. The formula I have written here. You notice it. So what should I write here? What is the number of element in A cross B?
M1 into M2.
Right, m1 into m2. So here I will write m1 into m2. So A cross B will have m1 into m2 number of elements. Now I want to know total number of relations from set A to set B. So what I want to know, total number of relation from set A to set B. And the definition of relation is it is a subset of A cross B. So A cross B has total m1 into m2 number of elements. So total number of subsets of A cross B. So it will be 2 raised to power m1 into m2. Like using the first formula, using this one. So A cross B has m1 into m2 number of element, m1 into m2 number of element. So A cross B will have subsets 2 raised to power m1 into m2. So that's why since every subset of A cross B is a relation from set A to set B as per definition. So therefore I can write the formula: total number of relation from set A to set B is 2 raised to power m1 into m2. Fine. So this is the formula. So this, and in exam they may ask you like that. So if set A has, so I write the question. So you use this formula and tell the answer. Just you can note down these two formulas. So I will write the question based on these two. Okay. So I told tell that total number of relations from set A to set B. Set A has m1 number of elements. Set B has m2 number of elements. Then total relation will be 2 raised to power m1 into m2. So now I will ask you the question. So since your exams are in MCQ mode, so question may be like that: if number of element in set A is 4, number of element in set B is 5, then total number of relations from set A to set B. Okay, each. So options are like, suppose they may give you 20, they may give you 2 raised to power 20. Okay, they may give you 4 raised to power 5, or they may give you 5 raised to power 4, like this. Okay, so these are the four options. So tell me which one is correct.
The 20.
B.
Hmm.
Option B.
So now you read the formula, these two formula you read, only second formula is enough. Now you try. So read that second formula again, and then you tell me what I asked the number of relations from set A to set B. Yeah, so one of you already
The 2
answered.
raised.
2 raised to power.
Option B, sir.
Yes, yes. So so option will be, so this type of questions will be asked in exam. Okay, so option is B. Okay, so when A has 4 elements, B has 5 elements, so how many relations from A to B you can define? That is 2 is about 20. Because formula is, this is M1 is 4, M2 is 5, so M1 into M2 is 20, and formula is total relations 2 raised to power M1 into M2, so 2 raised to power 20. Okay. Now, so this was a part. Now let's back to that. So I was telling you, A was, I have taken 1 2. Okay, B I had taken 3 4, no 3 4 5. So I had taken 3 4 5. So we have already calculated A cross B, and it was 1 3 2 3. Okay, uh, 1 4 2 4, then 1 5 2 5. Okay, 1 5 2 5. Now I already told you total number of relations here, total number of relations from A to B. So here I told you 2 raised to power 6. There are 6 elements in A cross B, so 2 raised to power 6, that was 64. This I told you. Now I want, there are 64 relations. So can you tell me any one relation? So now I will write R1. R1 means first relation. So we know that there are 64 relations from A to B. So my question is, can you tell me any one relation out of that 64? So indirectly I'm asking the subset of A cross B. Yeah, tell me any one subset of A cross B. So any subset of A cross B is a relation. So there are 64 relations from A to B. So tell me any one of the relations out of the 64.
Sir, out of 64, 6 are given on the screen now.
Yes, actually there are 64 relations, and this is A cross B. Okay. So what is a relation? A relation is subset of A cross B. Subset of A cross B. So how will you write the subsets? So okay, let me tell you. What is a subset? So for example, just for your information, Let me write here. Suppose like A is set containing मान लो ऐसा है A B C D. These are four elements. So it will have total subsets. It will have total subsets. It will have 2 raised to power 4. So A has 4 number of elements. So a total subset it will have 2 raised to power 4. That is 16. So what are those? If I want to write, the first subset is empty set. Empty set means there is no element. So first subset is, smallest subset is empty set. Then you can write singletons. Singletons means set containing A, set containing B, set containing C, set containing D. These are called singletons. Singletons means one element. Then you may write the subsets containing two elements like AB, BC, AC, na? CD. One minute. AB, BC, AC, AD, AB, AC, AD content. Yeah. Then BC, BD. Sets we write always curly bracket. That's why I'm writing curly bracket. Subset is also a set. So BD and then CD. So these are the elements containing. These are the subsets containing two elements. Similarly, you may write the subsets containing three elements. For example, A, B, C. Okay, A, B, D. Like that, if you write. So okay, I have written it there. I will write only A, B, C, A, B, D. Then like A, C, D. Okay. Then it's B, C, D. Okay. Then I will write. Yeah, these are actually ABC, ABC, ACD, BCD. That's all. So these are the elements containing subsets containing four elements, and the largest subset is set itself. So A, B, C, D. Okay. So largest subset is set itself. So these are 16. You may count. I have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are total 16 subsets. Similarly, so I have taken here four elements. If I would have taken like six elements here, so there would be 64 subsets. Similarly, we would write empty, singletons, then two elements, three elements, like that. Okay, come to that point. So here we have A cross B. Now you have to tell me any one subset of A cross B. Tell me any one subset of A cross B. Tell me any one subset of A cross B. Like you have seen, I have given you one example there. So this is like A, this is like B, this is like C, this is like D, E, F. There are six elements here. So in similar manner, you will write there are 64 subsets. So you tell me any one subset. Yeah, tell me quickly. Okay, so I will tell you. Like you can write empty set. Empty set is subset of every set. So one. Second you want just singleton, 1, 3. Third you want singleton, 2, 3. Like that. Okay. So largest like 64 subset you will write R.
Good night.
64 is like 1, 3, 2, 3, 1, 4, 2, 4, 1, 5, and 2, 5. Okay. So this is. So I would like to tell you that if someone is speaking something, so meeting is being recorded. So I can see the recording, I can identify the name. So if someone is speaking something, if it is by mistake, it's okay. If you are doing knowingly, then we may punish you. So it is being recorded, right? So your name will be there if you speak. So unnecessarily, you cannot speak anything. Okay. So this is subset. Okay, so these are all relations. Okay, this is one relation, this is the other, like that. So what I was doing till now, I was defining the relation from set A to set B. So what we are defining? Relation from set A to set B. So mathematical way we write like this, or this is set A, this is set B. We are defining a relation, okay, from set A to set B. So like also we write the definition you have seen. Relation is a subset of A cross B. So mathematical formulation is like that. Or R will contain order pairs, something like A cross AB, and some relation will be there. Okay. So you can remember one formula that relation from set A to set B, there are two raised to power m1 into m2. है ना? This was if m1 is the number of element in set A and m2 is the number of element in set B. Now we'll write next term, a relation on set A. Now you have only one set. You don't have two sets. Okay. So like we were defining relation from set A to set B, plus set A to set B, and now we want to define relation on set A. On set A means relation from set A to set A only. Okay. So similar way, like there we had relation from A to B. So B we replaced by A only. So there when R is a relation from A to B, R is a subset of A cross B. So when R is a relation from A to A, so R is a subset of A cross B. Okay. So this is the definition. So relation on set A means a relation from set A to set A, and that will be a subset of A cross A. For example, A if we consider 1, 2. Okay, so A cross A. So you will multiply set A by set A only. So it will be like 1, 1, 1, 2, है ना? 2, 1, 2, 2. Okay, so this is A cross A. And again, any subset of A cross A will be a relation on set A. Okay, so subsets of A cross A is a relation on set A. This is mathematical definition of relation on set A. Okay. So for example, if I want to write any one relation, so that you can write empty. Empty set is subset of every set. So empty set is a subset of A cross A also. R2. R2 you may take any singleton element. So 1, 1 is a singleton element. R3 you may take pair if you want, like 1, 2 and 2, 1 you may take together. So R1 means first relation, R2 means second relation, R3 means third relation. So how many total relation I can define on set A? How many total relation I can define on set A? So see, if number of element in set A is m, suppose. Okay, so only one set we have, so I'm taking m. So number of element in set A is m. Then number of element in A cross A. So that will be what? Anyone tell me? So if A has m number of elements, so A cross A has how many elements? Set A
M
has,
square.
right, m square. Okay, so this is m square, m into m. Okay, so m square, and now you may write m into m. Okay, so A has m elements, A cross A has m square elements. So total subsets of, so total number of subsets of A cross A. What will be total number of subset of A cross A? Yeah, tell me anyone. Quickly.
2 to the power m square.
Right, 2 raised to power m square. Fine. And any subset of A cross A is a relation on set A. So that's why you can write total number of relations, total number of relations on set A, that is 2 raised to power m square. Fine. So this is a formula. So again, in exam, if they give you, like suppose set A has 3 elements, so how many relations on set A can we define? So the answer will be, in case if they give you suppose number of element in a set A is 3, so you just use this formula. Okay, so if number of element in A is 3, so total relation on A, total relation on set A, so that is 2 raised to power m square. M is 3 here, so 2 raised to power 3 square, 3 square is 9, 2 raised to power 9 is 512. So set A has 3 elements, then total relations you can define on set A are 512. So you may write all if you want, because A has 3, so an A cross A will have 9 elements, and then if you write all subset of A cross A, you will get subsets, and that subsets are relations. So you will get relations. Okay, so this is again one important formula, है ना? Question may be asked on that. Okay, So this question is inside your notes also, like if they provide you then. Okay, so now we have types of relations. Okay, Acha, I will tell you one relation explicitly. Okay, suppose A is 1, 2, 3. Okay, and relation we define on set A. On set A means A to A, and relations defined like A comma B such that A plus B is more than 2. Suppose, yeah. So what they want to tell? It is a mathematical relation. Okay, so A and B are related. Matlab A is from set A, B is from A. So actually this relation is from A to A only. So first element is from A and second element from A only. Yeah? If relation is from A to B, then first element from A and second element from B. So here small a belongs to this capital A and small b also belongs to capital A because relation from A to B. And they are telling that A and B, these two are actually elements of set A only. Okay. And A will be related to B. So this is the condition. This is a mathematical relation. So A का relation B के साथ होगा अगर A plus B का sum 2 से ज़्यादा है. Okay. So now you select. In A is a family. Okay. Set is a family. So it has three members. 1, 2, 3. अब बताओ किस एलिमेंट का रिलेशन किसके साथ होगा अकॉर्डिंग टू दिस डेफिनेशन. So tell me, this form is called like set builder form, and now I want to write this in roster form. So there is a one form called roster form. So explicitly we write elements there. So tell me, which elements of set A are related to which one? So definition is A is related to B if A plus B is more than 2. So tell me, select two elements from set A which satisfy this condition. इतना टाइम लगेगा? कोई दो नंबर बताओ सेट ए में से.
1 3.
हाँ 1 3 because 1 plus 3 is more than 2. Fine, yes. Now
2 3.
2, 3.
2 3 is also correct. More
3 1
3 1, yes.
and 3 2.
3 2, yes. Next
1 2 3.
no pair wise in relation you only write
Yeah.
order
Okay.
pairs. Okay, order pairs we write. So pair wise, two elements you will take. So 1 related to 3, 2 related to 3, 3 related to 1, 3 related to 2. Okay, can we say 1 related to 1? Can we say 1 is related to 1? So what is 1 plus 1?
No, sir.
No, 1 plus 1 is
No.
not more than 2. That's why. So 1 is not related to 1. Can we say 2 is related to 2?
Yes, sir.
Yes,
Yes,
sir.
because 2 plus 2 is more than 2. That's why. Can we say 3 is related to 3?
Hmm.
Yes.
Yes, sir.
So 3 3. So what we have written? Actually, A has 3 elements. So A cross A will have 9 elements. So there will be 8 elements here, excepting one, right? So 1 2. So you may write 1 related to 2, 1 related to 3 already there. Then 2 related to 1. So you may write 2 related to 1, 2 related to 2 already there, 2 related to 3 is there. Okay, 3 related to 1, 3 related to 2, 3 related to 3. There are 8 elements here. Sorry, 7, 3, 3. Sorry, कितना है? 3, 6, 8, 8. Fine. So A has actually 3 elements. So A cross A will have A cross A will have total 9 elements if you want to find. And actually a relation is nothing but a subset of A cross B. So you may do this question in other way also, like you first find A cross A, and that will be, and you will be multiplying these two sets. You will be multiplying these two sets, and that will be like 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. So Cartesian product contains only order pairs. And since relation is a subset of A cross A relation on set A is a subset of A cross A. So you select those elements from this A cross A which satisfy this condition. So condition was A will be related to B only if A plus B is more than 2. So this will not satisfy, all will satisfy that condition. So these all are here. Okay. So this form is called, so like I will write here only 2 1 and remove it from here. So this form is called roster form. So this is called roster form. Okay. Now there is one more way of writing the relation, that is called arrow diagram. A and A. We are writing relation on set A. So A has 1, 2, 3, and A has 1, 2, 3. Now you will see into this relation. So 1 is related to 3. So you may define like 1 related to 3, 2 related to 3, 2 related to 3, 3 related to 1. So 3 related to 1, 3 related to 2. So 3 related to 2, 2 related to 2. So 2 related to 2. Then 3 related to 3. 3 related to 3. 1 related to 2. So 1 to 1 only, 1 related to 1. And then 2 related to 1, 2 related to 1. So only 1 1 is not there. So like 1 is not related to 1. Now you may define something else, or in exam they may define something else. So this is set builder form, roster form, and this is called arrow diagram. Okay. So now I will define types of relations. So mainly you have here reflexive. So the first here will define reflexive relation. A reflexive relation. Okay. So we'll define reflexive relation. So what is reflexive relation? So we are defining a relation actually from A to A only. Relation on a set. Okay, we are defining relation on a set A to A, or we can write a relation on set A. Same thing. We may write we are defining relation on single set A. So we're defining a relation on set A. Okay. Now, what is reflexive relation? What is the definition? So definition according to book, they say a relation on set A is reflexive, or is called reflexive, is called reflexive if, so if the main condition is this. So right here, if A comma A belongs to R. So belongs to R means A is related to A. The every element is related to itself for all A belongs to capital set A. So this is the main definition of reflexive. So like in word, if you want to write, so in word if I write, that means they want to tell every element of set A is related to all elements of A. Oh, sorry. A belongs to A, na? So A means every element is related to itself. At least. At least means it is not restricted to only. At least it must be restricted to itself. So this is sufficient. You don't write at least, this is sufficient. So if every element of set A is related to itself, then we call that relation is reflexive. Okay. Okay, so now I will ask you, I will write one example and I will ask you. So example is from book only. Just you remember this part, either in word you remember or in mathematical way this. So A belongs to R for all A belongs to A. So every element of set A are related to itself. That is required. Every element must be related to itself. So example, suppose set A I write. So in the book they write like 1, 2, 3, 4. So we are defining relation on this. The first part is R1 we have written. It is like 1, 1, 1, 2, 2, 1. Okay, tell me, is this relation reflexive? So you may see the definition. Can we say this relation is reflexive? Yes or no? Elements are 1 1 1 2 2 1. 1 1 1 2 and 2 1.
No, sir.
Why? Answer is right. So why do you think so? Just you
Because
justify.
there is no 2 2.
Right, right. So 2 is not related to 2. Okay. 1 is related to 1, but that is not enough. It is saying that every element must be related to itself. So set A has 4 elements. So all 4 elements must be related to itself. So here 1 is related to 1, but 2 is not related to. So looking at this is not reflexive. This is not reflexive because 2 2 does not belongs to relation R. Okay, means 2 is not related to. So all elements must be related to itself. Then you will call it reflexive. Okay. Next, second part, like R2, if I write 1 1 2 2 1 2 2 1. Now, is it reflexive now? 1 1 2 2 1 2 2 1. Is it reflexive? Yes or no?
Yes, sir.
So ए में कितने एलिमेंट है? सेट ए में कितना एलिमेंट है? 4 ना?
Yes.
बट यहाँ 1 1 से रिलेटेड है, 2 2 से रिलेटेड है, बट क्या 3 3 से रिलेटेड है?
No, sir.
नो.
No
सो दिस इज
reflexive.
नॉट रिफ्लेक्सिव.
Yes.
अगर 3 3 रख देंगे तब भी नहीं होगा, क्योंकि 4 4 नहीं होगा फिर.
4 4. Yes.
राइट. सो टू बी रिफ्लेक्सिव all elements must be related to itself. So this is not reflexive even because 3 3 does not belongs to R. Okay. So even if you put 3 3, still it will not be reflexive because of 4 4 must be there. So like I will write the example third. Suppose R3 I write 1 1 1 2 2 2 2 3 3 3 4 4. So is it reflexive now? So can we say 1 1 1 2 2 2 2 3 3 3 4 4? Is it reflexive? Yes or no?
Yes, sir.
So 1 1 is there, 2 2 is there, 3 3 is there, and 4 4 is there. So all elements of set A are related to itself. That's why it is reflexive. So yes, this is a reflexive relation. This is a reflexive relation. This is a reflexive relation. Okay. So this is a reflexive relation. So you can identify it. Okay. And these extra elements are like we don't need to look at that. Only we have to look that whether every element is related to itself or not. Okay. That's enough for reflect. If extra elements are there, not there, it will not affect the reflexivity. So only you need to see that every element must be related to itself. Okay. So next we have okay. So I will add one more example. So like okay. So next question, like it said, is the device division relation on set of positive integer reflexive? So like we define a relation on positive integer, okay, z plus, or we call it natural number. Okay, so we define natural number to natural number. So you all know natural number, I think. So that I was writing set A. So set A is natural number here, 1 2 3 and so on. So we are defining relation like R is A comma B such that A upon B belongs to R, or sorry, A upon B is A divides B. You may write like that. So is the division relation this? So I may write A divides B. Like A divides B. This is the relation. Okay. So relation is a and b, these are two natural number, and a will be related to b if a divides b. So a divides b means a divides b, so b is multiple of a. Writing this is same as writing b is multiple of a. Okay, so question is it reflexive? So is it reflexive relation? So simple, you need to check whether all so you need to check whether AA belongs to R or not. This you have to check. So AA belongs to R means uh, A divides A or not. So tell me this line is true or not. A divides A. Every number divides itself. True or false?
True.
True.
True. So that's why it is reflexive. True. So this is reflexive. Therefore R is reflexive. R is reflexive. Okay. R is reflexive. Okay. So relation is reflexive. Okay. So every you may write explanation here. Every integer divides itself. Every natural number divides itself. That's why it is reflexive. So you may write in word. Every number divides itself. That's why it is reflexive. Every natural number divide itself. So therefore, it is reflexive. Therefore, this relation is reflexive. So divides means they are related. The definition here is this: AB will be related if they are divides each other. So there are more types, but so like next class if I teach or anyone will teach, so you tell them to start from this symmetric relation. So next is reflexive is this, next is symmetric, then transitive. They will teach you. Then equivalence. I think this you have done. So why didn't tell you already? Have you done this? Reflexive, symmetric, and all.
Yes, sir.
So why didn't tell you in the beginning? Because you should tell me na at least that this part has been covered or not. Okay, so how will I take the attendance? So for the attendance thing, I will share you a Google link form. Okay, 1 minute. Okay, the chat option is there. Uh, so inside chat, I'm putting the link to fill this form. So that will be attendance form. Okay, so you just fill this form. That will be attendance for today.
Excuse me, sir.
Yes, yes.
Sir, my chat box is not opening. It's saying that it's only available for team members.
Chat box. So tell anyone to send you through WhatsApp or something. Anyone of your friend.
Okay, sir.
Okay, so everyone filled. So just fill it quickly, otherwise I
Yes,
will.
sir.
Okay. Okay, so I'm closing now. Okay, thank you everyone. Thank you.
Thank you, sir.